Hello, welcome to Physics Explained, where physics problems meet with proper step-by-step solutions and intuitions. So let's dive into today's problem. Here it is said that a triangular prism of mass m is placed one side on a frictionless horizontal plane as shown in figure 1. The other two sides are inclined with respect to the plane. One angle is alpha 1, another angle is alpha 2. Two blocks of mass m1. M1 is on left side, m2 is on right side of the wedge. It is connected by an inextensible thread, can slide without friction on the surface of the prism. The mass of the pulley which supports the thread is negligible. Express the acceleration A of the blocks related to the prism in terms of acceleration A naught of the prism. Find A naught in terms of G. At what ratio of 1 by m2 the prism will be in equilibrium. So let's start. Here is the horizontal plane. This is the wedge. I will say it as wedge, not prism. This is alpha 1. This is alpha 2. That's a pulley. M1 on the left side, M2 on the right side. Frictionless. The mass of the wedge is capital M. Okay. Uh, then our first task is find A in terms of A naught. Acceleration of the works relative to prism, relative to wedge. So let's see. You know what if A naught equal to 0? That means the wedge is fixed. If the wedge is fixed, you will say that here is M1, here is M2. M1, suppose M2 is greater than M1, so M2 will move down the incline with acceleration A. M1 will move up the incline with acceleration A. So if I say the wedge M moving towards left with acceleration N, here the uh, wedge frame equal to ground frame because there is no acceleration. It is an inertial frame of reference, but this is a non-inertial frame of reference. Here if we see from wedge frame of reference, then we have to apply pseudo forces. Pseudo forces. So here it is M1. Here it is M2. From wedge frame of reference, I will see M1. Let M2 is greater than M. From wedge frame of reference, because from wedge frame of reference the acceleration of the wedge is 0. That means similar to the previous case. So M1 will move up along the incline with acceleration A. Let M2 will move down along the incline with acceleration A. But from ground frame of reference, in this case, M1 have two acceleration. One along the incline up with A, another one is A naught towards left. Similarly for M2, acceleration A down the incline, A naught towards left. Here you can see that if I goes to wedge lock frame of reference, then I will use pseudo force. Here is M1. This is one acceleration along the incline towards up. One is A naught towards right. The pseudo force acceleration will act towards right because the block is moving towards left. So here the A naught cancels. From block frame of reference, I see M2, M1 with acceleration A is moving up along the incline. Similarly, M2 will move down along the incline wedge frame of reference. But from ground frame of reference, this is the scenario. So let's try with a BD of mass M1. Here is the mass M1 resting on the incline. This is the angle alpha 1. This is M1G. This is the normal N1. This is the tension T. Let's resolve into the components along this axis. This angle is alpha 1. As these lines are parallel, this will be alpha 1. This is T cos alpha 1. This is T sin alpha 1. Only this is alpha 1. This angle will be also alpha 1. This is 90 degree minus alpha 1. This horizontal component of normal will be n sin alpha 1. Vertical component will be n cos alpha 1. Accelerations m1 in direction a, another one is the left towards a naught. This is alpha 1, this will be alpha 1. So a has component in horizontal a cos alpha 1, vertical component a sin alpha 1. Now if write equation, so along vertical equation is t sin alpha 1 plus n cos alpha 1 minus m1g is m1 a sin alpha 1 horizontal equation n sin alpha 1 minus t cos alpha 1 is m1 a naught minus a cos alpha 1. Let's say this is equation 1, this is equation 2. Now a BD of mass m2. This is m2, this angle is alpha 2, m2g vertically downward. This is normal n2. There is a tension T. Tension will be same in the string because there is only one string and it is inextensible. Sorry. As this angle is alpha 2, this will be alpha 2. And so this component will be T cos alpha 2. Along vertical it will be T sin alpha 2. Normal, this is alpha 2. This will be 90 degree minus alpha 2. Normal is a horizontal component n2 sin alpha 2. Vertical component n2 cos alpha 2. M2 has acceleration a in this direction and not towards left. This angle is alpha 2. This will be also alpha 2 as these are in parallel. So a in horizontal direction a cos alpha 2, vertical direction a sin alpha 2. Now writing the force equations in vertical direction T sin al sorry this is the m2g minus T sin alpha 2 minus n2 cos alpha 2 is equals to m2a sine alpha 2 in horizontal direction. T cos alpha 2 minus n2 sine alpha 2 is equals m2 a naught minus a cos alpha 2. This is equation 3. This is equation 4. Now FGD of wedge having mass m. This is mass m. There's a pulley tension in this direction, tension in this direction. There is N1, N2. This angle is alpha 1. This angle is alpha 2. So, uh, is a force mg and normal from ground and capital acceleration m along this a naught. So now resolve these forces. This angle is alpha 2. This is also alpha 2. This is 90 degree minus alpha 2. So this component will be n2 sine alpha 2. This is n2 cos alpha 2. This angle is alpha 1. This will be alpha 1. This is 90 degree minus alpha 1. So n1 has horizontal component n1 sine alpha 1, vertical component n1 cos alpha 1. Now resolving tension. This angle is alpha 1. This is alpha 2. Tension in component in horizontal direction T cos alpha 2, T sin alpha 2, T sin alpha 1, T cos alpha 1. Now I am writing the horizontal equation. So this will be T cos alpha 1 minus T cos alpha 2. Now the normal components plus N2 sin alpha 2 minus N1 sin alpha 1 equals MA naught. Vertical force equation will be normal M equal to mg plus n1 cos alpha 1 plus n2 cos alpha 2, sorry, plus t into sin alpha 1 plus sin alpha 2. This is equation 5. This is equation 6. So we got 6 equations. Now we have to find A in terms of A naught. So we have given M1 is given, M2 is given, capital M is given, alpha 1, alpha 2 is given. Variables are A, A naught is also given. We are taking this because we have to find in terms of A naught. A, then N1, N2, N, then so. So we have to eliminate this gas. So if you observe here equation 1, equation 2, n sin alpha 1 minus p cos alpha 1. In equation 4, p cos alpha 2 minus n2 sin alpha 2. In equation 5, p cos alpha 1 minus p cos alpha 2 plus n2 sin alpha 2 minus n1 sin alpha 2. So if we add equation 2, 4 and 5, then the t, n2, n1 components vanishes. So let's add equation 2, 4 and 5. Equation 2 is basically n sin alpha 1 minus p cos alpha 1. N sin alpha 1 minus p cos alpha 1 is m1 a naught minus a what minus a cos alpha 1. Okay, then the fourth equation is p cos alpha 2 t cos alpha 2 minus n sin alpha 2 equal to m2 a naught minus a cos alpha 2. Then the fifth equation t cos alpha 1 minus t cos alpha 2 t cos alpha 1 minus t cos alpha 2 plus n2 sin alpha 2 minus n1 sin alpha. So here this is n1, this is n2 plus n2 sin alpha 2 minus n1 sin alpha 1. This is m n naught. Add n1 sin alpha 1, n1 sin alpha. Cancels. This tension components also cancels. N2 sin alpha 2, N2 sin alpha 2 cancels. This becomes m a naught equal to sorry plus m1 a naught minus m1 a cos alpha 1 plus m2 a naught minus m2 a cos alpha 2 equals 0. If we solve, a becomes a naught into m plus m1 plus m2 divided by m1 cos alpha 1 plus m2 cos alpha 2. This is the answer. Equation this is let 7. Now the B part find acceleration A naught of the prism in terms of quantities given the acceleration G. We have to find B part A naught in terms of G. So how can we find? So we have a expression A in terms of A naught. If we find another expression A in terms of A naught, then we will then eliminate A and find N. So I will use the tension here because the tension in M1 and M2 is same. So equation 1 is this T sin alpha 2 plus N cos alpha 1. Second equation is N sin alpha 1 minus T cos alpha 1. I think I missed to write N1 N1 here. Second is correct and 2 okay. So if we multiply in equation 1 sin alpha 1 in equation 2 cos alpha 1, then if I subtract, then they will be cancelled. So let's multiply in equation 1 with sin alpha 1. Equation 1 sin alpha 1. So this becomes T sine square alpha 1. Okay. T sine square alpha 1 minus n1 cos alpha 1 sine alpha 1 minus, I think there's a minus sign, minus m1g sine alpha 1 minus m1g sine alpha 1 equals m1 a sine square alpha 1. Okay. m1 a sine square alpha 1. Then equation 2 with cos alpha 1. This becomes n1 sine alpha 1 cos alpha 1 is t cos square alpha 1. This is m1 cos alpha 1 a, a naught minus a cos alpha 1. This is correct. n1 t cos square m2 cos a naught a cos. Okay, this is correct. So if we solve tension from here, this will be minus sign minus y. Just add it. Have I missed something? Okay, there is a plus sign in the equation. So change the sign, minus minus. This will be plus. This will be minus. These two will be cancelled. T sine square alpha 1 plus cos square alpha 1 minus m1g sine alpha 1. This is m1a sine square alpha 1 minus m1 a naught cos alpha 1 minus 1 is plus m1 a cos square alpha 1. Here is sine square alpha 1 plus cos square alpha 1. Here is sine square alpha 1 cos square alpha 1. So you take out common. So this sine square alpha 1 plus cos square alpha 1 becomes 1. T minus m1g sine alpha 1 equals m1a minus m1 a naught cos alpha 1. T equals m1g sine alpha 1 minus m1 a naught cos alpha 1 plus m1a. That's this is equation 8. Now for m2 mass. Equation third and fourth. Okay. Equation third. This is m to the minus t sin alpha 2 minus m2 cos alpha 2. Equation fourth t cos alpha 2 minus n2 sin alpha 2. So if I multiply equation 3 with sin alpha 2 and multiply equation 4 with cos alpha 2 and then minus, this n2 will be cancelled out. Okay. So equation 3 with sin alpha 2. Equation 3 into sin alpha 2. This becomes m2g sin alpha 2. Then what's that? m2g sin alpha 2 minus t sin square alpha 2. Okay. Minus t sin square alpha 2 minus n2 sin alpha 2 cos alpha 2 equals m2 sin alpha 2. Okay, m2 sin square alpha 2 into a. Then equation 4 with cos alpha 2. Question 4 with cos alpha 2. T cos square alpha 2 minus n2 sin alpha 2 cos alpha 2. Okay. T cos square alpha 2 minus n2 sin alpha 2 cos alpha 2. This is m2 cos alpha 2 a naught minus a cos alpha 2. Now minus this will change minus sign, this is plus sign, this is change minus sign. This cancels out. So this is m2g sin alpha 2 minus t sin square alpha 2 plus cos square alpha 2. This is m2a sin square alpha 2 minus m2a naught cos alpha 2 plus m2a cos square alpha 2. Here this is sin square alpha 2 cos square alpha 2. This is your sin square alpha 2 cos square alpha 2. This will become 1. So m2g sin alpha 2 minus t equals m2a minus m2a naught cos alpha 2. Tension T is m2g sin alpha 2 plus m2a naught cos alpha 2 minus m2a. This is equation number 9. Now as both tensions are same, let's equate equation 8 equals equation 9. Equation 9 is here m2g sin alpha 2 plus m2a naught cos alpha 2 minus m2a equals m1g sin alpha 1. m1g sin alpha 1 minus m1 a naught cos alpha 1 minus m1 a naught cos alpha 1 plus m1 a. Okay. So we are going to say g common m2 minus sorry m2 sin alpha 2 minus m1 sin alpha 1, then plus m2 cos alpha 2 plus m1 cos alpha 1 into a naught equals m1 plus m2 a. So this is equation 10. Now we have in equation 7 a in terms of a naught. So let's put in this equation. So here it is g into m2 sin alpha 2 minus m1 sin alpha 1 plus m2 cos alpha 2 plus m1 cos alpha 1 a naught is basically m1 plus m2 mm, a naught m plus m1 plus m2. Okay, a naught m plus m1 plus m2 divided by I think m2 cos alpha m1 cos alpha 1 plus m2 cos alpha 2. Okay, m1 cos alpha 1 plus m2 cos alpha 2. That's all. G m2 sin alpha 2 minus m1 Sin alpha 1, a naught common, m1 plus m2, m plus m1 plus m2 divided by m1 cos alpha 1 plus m2 cos alpha 2. This term is the denominator. So if I minus in the numerator, it will be square term. Okay. Minus m2 cos alpha 2 plus m1 cos alpha 1 square. Solve a naught. Okay. So a naught becomes g m2 sine alpha 2 minus m1 sine alpha 1 into m1 cos alpha 1 plus m2 cos alpha 2 divided by m1 plus m2 m plus m1 plus m2 minus m2 cos alpha 2 plus m1 cos alpha 1 whole square. Then the C part. C part, it is said that forward ratio of m1 divided by m2, the wedge will be in equilibrium. That means a naught equals 0. A naught will be 0 as g m2 sine alpha 2 minus m1 sine alpha 1 m1 cos alpha 1 plus m2 cos alpha 2 equals 0. G can be 0 as alpha 1 and alpha 2 are acute angle. M1 and M2 are also positive. This can't be 0. So here M2 sine alpha 2 minus M1 sine alpha 1 equals 0. So M2 sine alpha 2 divided by M1 sine alpha 1, sorry, equals M1 sine alpha 1. So M2 divided by M1 is basically sine alpha 1 divided by sine alpha 2. That's it. So this is the solution. Thanks for watching. If you have any question, you can write it down in the comment section. Let's meet in the next video.